Hey kids, good morning. I'm making this video on Saturday morning. It's the first instructional video of 2019, and it is the second to last lesson in Unit 5, which we'll be wrapping up this week. 5.9, Angles and Polygons. There is an IXL unit that has to be completed by Monday evening, Monday at 5 p.m. Okay, so the IXL unit is G2, and it pretty much is aligned to what the objective is for this lesson, which is to determine the sum of interior angles of a convex polygon and the measure of an interior and exterior angle of a regular polygon. What is a convex polygon? What is a concave polygon? What are irregular and regular polygons? A convex polygon, as you can see here and as you will note, is one with all interior angles being less than 180 degrees. Okay, so in a convex polygon, all of the interior angles do not measure anything bigger than 180. Okay, a hint for that is if you look at a polygon and it doesn't have any angles pointing inward, like this one has an angle pointing inward, then it is a convex polygon. A concave polygon is one with at least one interior angle measuring between 180 and 360 degrees. Okay, those are the differences. I'm going to refocus this camera so it may be fuzzy for a second. When looking at or trying to determine whether or not you are seeing a convex or a concave, the hint is that you'll see an angle that points inward like this one. If you see something like this, you know that you're dealing with a concave polygon. So it's almost like it caves in, okay? And so that's your hint. A concave polygon has one angle that caves inward. What is a regular polygon as opposed to an irregular polygon? Well, a regular polygon is one where all the sides and interior angles are of congruent measure. So for example, an equilateral triangle would be considered a regular polygon. A square would be considered a regular polygon. An irregular polygon is one where all the sides and angles are of unequal length and measure. So a scalene triangle would be considered an irregular polygon, as would perhaps a parallelogram or any quadrilateral or any polygon with different sides and angle measures. Okay, there's an investigation that follows this section here. Make sure you have all of this written down. We'll do this together. So the investigation is asking you to use a straight edge to draw convex polygons with 3 sides, 4 sides, 5 sides, and 6 sides. And so they gave you an example here. This is a 1, 2, 3, 4, 5-sided polygon. It's convex because all of the interior angles are going to be less than 180 degrees. Okay, and there's no angle that caves inward like in this case. All right, so they actually drew one here for us. And so it says the next part of the investigation is to draw all diagonals from one vertex. Okay, a diagonal is a segment that joins 2 non-consecutive vertices. Essentially, a diagonal is a segment that goes from one vertex to a vertex on the other side of the figure. Okay, so in this case, we took this same 1, 2, 3, 4, 5-sided, which would be called a pentagon. This is a pentagon because it has 5 sides. Okay, we drew this pentagon, and from one vertex, which is this one right here, we drew diagonals. Okay, so for example, we drew from here. We drew a segment that went from this vertex to that vertex. From here, we drew a segment that went from that vertex to this one. Okay, and what happened when we did that is that there were 1, 2, 3 triangles created. We know that every single triangle has interior angles that measure 180 degrees. In this case, there are 3 triangles in one pentagon. We were able to draw 3 triangles from just that one pentagon. So if we were to try to figure out, well, what is the measure of the interior angles of a pentagon, we would just need to multiply 180 times 3, okay? And when you multiply 180 times 3, you get 540. So this means that the interior angles of a pentagon sum to 540 degrees, because like we showed here, you can make 3 triangles and no more than 3 within this pentagon, okay? So it says on the third point is that by the triangle sum theorem, the sum of the measures of the interior angles of one triangle is 180. And so like we did here, we took that 180, multiplied it by the 3 triangles, and we got 540. We're going to try that again a couple more times, okay? And we're going to do that using these 3 shapes that I drew here, all right? So from this quadrilateral, how many triangles do you think we would be able to get? Well, let's see. From this vertex to that vertex, I can only get 1 diagonal here. Now, you may say we can get more than that, but we're really trying to not have overlapping triangles. How many non-overlapping triangles can we get in this situation? And in this case, we get 2, okay? 1 here, 1 there. They do not overlap, all right? So because we have 2 triangles here, we take the triangle sum theorem, which means that we know that triangle 1 is 180 degrees plus triangle 2, right? So triangle 1 plus triangle 2, which is also 180, when we add them together, would give us 360 degrees, okay? So the sum of the interior angles of a quadrilateral is 360 degrees. Where are you going to draw this? Where are you going to show this example? Anywhere where you have space on the page. What I would suggest you do is you do this yourself all the way down here. Okay, so do that down here in the space below. All right, and we're going to do that again with these other 2. And if you want to do that on your own, go right ahead. So we have a pentagon here. And I'm trying again not to have overlapping triangles, okay? So I can make 1 triangle that goes from this vertex to that one. That's 1. And then I end up with this quadrilateral here. And I know that in that case, I'm going to be able to split that quadrilateral into 2 triangles. And we dealt with a pentagon before, right? So we took triangle 1 plus triangle 2 plus triangle 3. And that's 180 plus 180 plus 180. Or we could look at it as 180 times 3. And that would give us 540, okay? So the sum of the interior angles of a pentagon is 540, which we saw in the investigation. Let's try that with a 1, 2, 3, 4, 5, 6, 6-sided polygon. And a 6-sided polygon is called a hexagon, okay? So this is a quadrilateral. That's a pentagon. And down here, this is a hexagon, 6 sides, okay? Again, let's go ahead and keep trying to make these non-overlapping triangles that go from vertex to vertex. So I have 1 here, right? That's going to be triangle 1. And then from this vertex, I get another one. That's triangle 2. And then from this vertex, I can make another one, triangle 3. And then it looks like I'm able to make 4 triangles here. Okay, and so again, if I take triangle 1 plus triangle 2 plus triangle 3 plus triangle 4, that means I'm taking 180 and multiplying it by 4. Okay, and when I do that, I end up with 720. What does that mean? It means that The sum of the interior angles of a hexagon is 720. Stay tuned for video 2, which is going to conclude the rest of this notes packet.